In this lesson you will learn about factors and prime factorization. So let's start with a few definitions. The first definition is a prime number. And the definition is an integer greater than 1 whose only factors are 1 and itself. So a few examples of prime numbers would be the number 2, 3, 5, and 7. Because if I list the factors of each of these numbers, each number only has factors of 1 in itself. So 1 times 2 is 2, 1 times 3 is 3, 1 times 5 is 5, and 1 times 7 is 7. But a composite number is an integer greater than 1 that has factors other than 1 in itself. And examples would be the number 4, 6, 9, and 20. If I list the factors of 4, 1 and 4 multiply to 4, but so do 2 and 2. For 6, we have 1 times 6 and 2 times 3. For 9, 1 times 9 and 3 times 3. And for 20, we have 1 times 20, 2 times 10, and 4 times 5. So the next definition is factors. And factors are numbers that divide evenly into a number. So earlier, I wrote the factors of 2 when we were defining prime number, and 2 has only 2 factors, which are 1 and 2. Whereas a number like 6 has 4 factors, 1 and 6 and 2 and 3. But a number like 9, because it's a perfect square, has only 3 factors, 1 and 9, and then just the number 3. So when you're listing factors, always write the pairs of numbers that multiply together to give you the number that you're checking. This way, when you have a perfect square, you know that you can stop listing your factors if your number is very large. And the last definition is prime factorization, writing a number as a product of prime numbers. So if I take the number 27, to write the prime factorization, you make a prime tree. And I always write the prime number on the left that's a factor of 27. So a prime number that's a factor of 27 is the number 3. So I put the prime number on the left, the composite number on the right, and I keep breaking down the composite number until all of its factors are prime. And the only way I can break down 9 is 3 and 3. So one way to write the prime factorization of 27 would be 3 times 3 times 3, or I could write it as 3 cubed since I have 3 3's. The next number I'll show you is 75. So when I write the prime factorization of 75, pick any prime number that's a factor of 75. And since this number ends in 5, the first number that comes to mind is a 5. 5 times 15 multiplies to 75, and then I want to break 15 down until all of its factors are prime. And there's only one other pair, which are 3 and 5. So when I write the prime factorization, I write the numbers in order from smallest to highest. 3 times 5 times 5, or 3 times 5 squared. So I'm only looking at the prime numbers when I'm writing the prime factorization. So I only took the 2 5's and the 3, and when we did 27, I only took the 3's because they're the prime numbers that multiply together to give us 27. So for this group of problems, the directions are to write all the factors of the number, and if the number is composite, to write the prime factorization. So the first thing I'm going to do is list the factors. This part takes the longest. So when I list the factors of 144, I always start with 1 and the number itself. So 1 times 144 is 144. The next number I check, and I just go in order, is 2. I know that 2 will work because 144 is even. And 2 times 72 is 144. The next number I check is 3. 3 I also know will work if I divide this on the side, because if I add up the digits of 144, 1 plus 4 plus 4 equals 9. Since 3 divides into 9, then 3 will divide into 144. So if you divide that on the side, 3 times 48 will give you 144. And 4 will also divide evenly into 144, because if I look above at the number 2, 2's pair is even. Since 72 is even, I just take half of 72 to find the number that's paired with 4. So I went from 2 times 2 to give me 4, and then 2's pair is 72. 72 divided by 2 to give me 36. 5 will not work because 144 does not end in 5 or 0, but 6 will work because its factors of 2 and 3 are both above. Since 3 times 2 is 6, I'm going to look at the pair, 3's pair, which is 48, divide that number by 2 to get 24. 7 unfortunately does not have a trick because 7 is prime, so the next number to check is 8, which I also know will work, because if I take half of 8 is 4, 4's pair is even, so I divide 36 by 2 to get 18. And then the number 9 will work, because I can use the same trick that I used for 3. Add the digits of the number, 1 plus 4 plus 4 equals 9. If 9 divides evenly into the sum, then it will divide evenly into the actual number. And if you divide that on the side, 9 times 16 is 144. 10 will not work because the number does not end in 0. And 11 doesn't work because in a 3-digit number, you want the middle number to be the sum of the two outer numbers. And that brings us to 12, which we should know that 12 times 12 is 144. So my list is finished because I've gotten to a perfect square. So that's why writing factors out this way is very good, because you know when your list is finished. Rather than just checking, does 1 work, does 2 work, does 3 work, you may forget some of its pairs. So this number is definitely composite. So to write the prime factorization, I make a prime tree. And I start with a prime number, any prime number that's a factor of 144. And I will just start with 2. Since the number's even, that was the first number that came to mind. Prime number goes on the left, composite number goes on the right. And then I just keep breaking up the composite number until all of its numbers are prime. So I broke up 72 into 2 and 36. Again, prime number on the left, composite number on the right. And then I break up 36, 2 and 18. 18 is 2 times 9. And 9 is 3 times 3. So don't worry if you start with a different number, or if you break up, say number 36 as 2 different pairs of numbers. At the end, you will end up, as long as you divide correctly, with 4 2's. Again, we just want the prime numbers, and 2 3's. So we can write the prime factorization as 2 times 2 times 2 times 2 times 3 times 3, or 2 to the 4th times 3 squared. Our next number is 87. And if we start listing the factors of 87, we always start off with 1 and the number itself. 1 times 87. I know that 2 will not work because 87 is odd, so that means I don't have to check any even numbers. 2 or 4 or 6, all of the even combinations are out. So I go right to 3. And I know that 3 will work because 8 and 7 is 15, And since 3 divides into 15, that means 3 divides into 87. And if you divide that out on the side, 3 times 29 gives us 87. So it turns out that these are the only 4 factors of 87. But if you weren't sure, you would just continue with your list, but since 87 is odd, only checking odd numbers, and stop when you get to the number 27 because we already have 29 on the list. So now that our factors are done, we take 87 and write the prime factorization, since this is a composite number. And the only way we can break up 87 is as 3 and 29 because both of those numbers are prime. And to write the prime factorization, the only way to write the prime factorization for 87 is 3 times 29. And our next number is 504. So I picked large numbers for this lesson in case your numbers are this large for one, and also you can apply it to easier numbers. So for 504, we have 1 times 504. This number is even, so I go right to 2. And if I take 504 divided by 2, it's 252. Next, I check 3. And if I add up the digits of 504, 5 plus 0 plus 4 is 9. So since 3 divides into 9, then 3 will divide into 504. And if you divide that out on the side, 504 divided by 3 is 168. Next I check 4. And I know that 4 will work because half of 4 is 2, and the number with 2 is even. So if I take half of 252, I get 126. And again, this number can be found just by going through long division on the side. I don't have to check 5 because 504 does not end in 5 or 0, but I know that 6 will work because its factors of 2 and 3 are both on the list. And if I divide 6 into 504, you'll get 84. And then 7, unfortunately, doesn't have a trick, but if you take 504 and divide it by 7, you will get 72. The next number to check is 8. And I know that 8 will work because half of 8 is 4, and 4's pair is even, and since 126 is even, I just take half of it, which is 63. 9 will also work because if we add the digits of 504, we get 9. 9 divides into 9, so 9 will divide into 504. And if you divide that on the side, you'll get 56. 10 will not work because this number does not end in 0. 11 will not work because the middle digit is not the sum of the outer digits. 12 will work because we have 2 and 6 on the list. And since half of 12 is 6, we just take half of 6's pair, which is 42. So I'll continue my list over here, and 13 will not work, and again 13 doesn't have a trick because 13 is prime, but 14 will work because if I look at the number half of 14, which is 7, I have 72. 72 is even, so I divide it by 2 to get 36. And then 15 will not work because the number does not end in 5 or 0. And if you calculate each one, 16 will not work because half of 16 is 8 and 8's pair is odd. So when you take half of numbers, it's the number that's paired with it has to be even. Otherwise, you'll just be checking by long division each time. We'll get 18 to work. And the last number to work on this list is 21 times 24. And these two numbers are 3 apart, There's nothing in between 21 and 24. And now we can write the prime factorization of 504. So I start with a prime number. I'll start with 2. 2 times 252 is 504. And now I just divide this number by 2 because it's even, always keeping the prime number on the left and the composite number on the right. And I know I'm finished when all of my numbers are prime. So I have 3 2's, a 7, and 2 3's. So I can write the prime factorization as 2 times 2 times 2 times 3 times 3 times 7, or as 2 to the third times 3 squared times 7. And the last example from this group of directions is 53. And 53 will turn out to be a prime number. Only 1 times 53 will give you 53, so therefore there is no prime factorization. Prime factorization is only for composite numbers. In this group of problems, the directions are to factor the monomial. And a monomial is just a single term. And in this monomial, 24ab is how this is read, or 24 times a times b is another way to read this. It's a monomial because the letters are being multiplied by the number. Whenever you don't have symbols in between letters and numbers, it means that they're being multiplied. So as long as they're being multiplied, no matter how many letters follow the number, it's considered a monomial. So to factor a monomial, we start by writing the prime factorization of 24 the same way that we wrote the prime factorization earlier, prime number on the left, composite number on the right. And when we're finished with the prime factorization, we end up with 3 2's and 1 3. So when you factor a monomial, you write it as 2 times 2 times 2 times 3, and then the variables to a single power, which a and b are already to the first, so this is the only way we can write the answer. Whereas on number 6, we have 4x cubed y squared. We start with the prime factorization of 4, which is only 2 and 2, and then we take x cubed and write it as x times x times x, and y squared, and write it as y times y. So that's all you have to do for factoring monomials. Just write each variable as a single power and write the prime factorization of the number. So for number 7, we'll start with 72's prime factorization. 72 is even, so 2 times 36, and then 2 times 18, and then 2 times 9, and then 9 is 3 times 3. So we end up with 3 2's and 2 3's. So we have 2 times 2 times 2 times 3 times 3, and we had m squared, so it's m times m. For number 8, list the factors of the monomial. This problem is fairly lengthy. So what we do when we're listing factors is, instead of making a prime tree, again, we do this just as we did earlier, we write all of the pairs of numbers that multiply to 60. So we have 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, and 6 and 10. But we also have this a squared at the end. That means that a is a factor, and so is a squared. So when we list the factors of the monomial, we want to start by writing the numbers that we listed in the factor list. And it doesn't matter the order, but I'm just going to write them in ascending order. And then you take each of these numbers and attach an A. So you also have 1A, 2A, all the way up to 60A. And then you take the same numbers and attach an A squared. So you have 1A squared, 2A squared, and again all the way up to 60A squared. So you're writing all combinations of the numbers and the variable. If it had been A cubed, we would have to write another row of all of the numbers and A cubed. And these are all of the factors of 60A squared. Next, for 56xy squared, again I start by listing the factors of 56, starting with 1. 56 is even, so we know that 2 will work. And when we list all the factors, we will end up with these 8 numbers. And then for my variables, I have x, y squared. So one possibility as a factor is x, another one is y, and another one is y squared. But then I also have a combination of x and y and a combination of x and y squared. So for this example, I start by listing the numbers 1, 2, 4, 7, 8, 14, 28, and 56. And then I take all combinations with the variables. So I had x only, y squared was y and y squared, but then also combinations of x and y squared. So my next row, I'll have all of these numbers above with an x. So these just take a long time, and if the number was higher than 56, like 144 that we had earlier, then this list would have been even longer. Now I move on to y. And then I move on to y squared. And then xy. and then finally xy squared. And these are all of the factors of 56xy squared. And the last question is a multiple choice question. What is the prime factorization of 36? And one thing that you can do on a multiple choice test is you can go right to the answers and check to see which of the answers multiplies to 36, which is fine. The only thing you want to look out for is when they ask for prime factorization, that means that all of the numbers have to be prime. And prime by definition is a number greater than 1 whose only factors are 1 in itself. So in part A, we have the number 1. 1 is not a prime number, so there's no need to check if choice A multiplies to 36 because 1 is not a prime number. The same with choice D. Even if D multiplied to 36, you have the number 4, which is also not a prime number, so D is out. So now it's just a matter of checking choices B and C. B multiplies to 36, C multiplies to 54, so the answer is B.